Hey there, statisticians. Welcome back. This is like take 3. Let's see if I can make this one make sense. So when we draw conclusions, we draw a conclusion about an entire population from a sample. And sometimes that sample will not reflect the population truly. Okay? Because my sample does not always reflect the population accurately, we can make type 1 errors and type 2 errors. Now, I don't like that the book is calling them a mistake. We did everything right. Just our data from the sample does not truly reflect the population. All right, so let's take a look at this. Let me see if this will make sense. So our two types of errors are type 1 errors and type 2 errors. I don't like this first part. I struggle, I'll be honest, I struggle with this first part. A type 1 error occurs if we reject the null hypothesis when the null hypothesis is true. I don't like that part. The part I like, a type 1 error happens. So my type 1 error says the data gives convincing evidence that the alternative hypothesis is true when it really isn't. So what this is saying, my p-value is going to be less than alpha, because that leads me to believe that leads me to that convincing evidence for the alternative hypothesis is correct. However, this is not what the population shows. So the p-value is less than alpha for the sample, but not the population. So we have a small p-value, and that leads me to believe I have convincing evidence for the alternative hypothesis. However, the population doesn't show that as well. Okay? So it's true for the sample, but not true for the population. Type 2 errors. This says a type 2 error occurs when we fail to reject the null hypothesis when the alternative hypothesis is true. I don't like looking at it that way. I like to say the data do not give convincing evidence that the alternative hypothesis is true when it really is. So what that means, when I look at my sample, what this is saying is I'm going to have a large p-value. My p-value is going to be greater than alpha for this sample. But again, the population does not reflect that. Okay, so a type 1 is, I look at my data, I get a small p-value. Type 1 is small, so I do get a small p-value. However, the population, I should have had a big p-value. I should have not rejected the null hypothesis, but I did. And then type 2 is bigger. I get a big p-value, and I should have had a small p-value. That's the way we're going to try to keep it straight. 1 is this, I got a small p-value, I should have had a big p-value. 2, I got a big p-value, I should have had a small p-value. Okay? I think that'll help us keep them straight. So not only do you have to be able to describe a type 1 and type 2 error in context of a problem, you've got to talk about the consequences of making that error. And now when we say error, that doesn't mean we did anything wrong. We didn't do anything wrong per se. The sample we have does not reflect the true population. Fun fact, the probability of making a type 1 error is alpha. Kind of cool. And because the probability of making a type 1 error decrease the probability of making a type 1 error by using a smaller significance level. Because if you say alpha is 10%, I have a 10% probability of making a type 1 error. And a type 1 error, if we go back, type 1 means I'm going to get a small p-value when I should have gotten a big p-value. Because my p-value went under the 10%, and it should not have been under 10%. It should have been over the 10%. So decrease the probability of that happening by choosing a smaller value for alpha. Boom. Hopefully that helps. Type 1 and type 2 errors can be a bit tricky. So let's see some real world applications of these types of errors. So television networks rely heavily on ratings of TV shows when deciding whether to renew a TV show for another season. Suppose a network has decided that Miniature Golf with the Stars will only be renewed if it can be established that more than 12% of U.S. adults watch the show. Polling company asks a random sample of 2,000 U.S. adults if they watch Miniature Golf with the Stars. The network uses the data to perform a test of null hypothesis, P equals 0.12, and the alternative hypothesis, P is greater than 0.12, where P is the true proportion of all U.S. adults who watch the show. Describe a type 1 error and a type 2 error in this setting and give possible consequences of each. Now, these errors are occurring not because the company did anything wrong. We didn't talk to every single U.S. adult. We only talked to 2,000 U.S. adults. Now, do those 2,000 U.S. adults have to agree with the entire population? That answer is no. No, they don't. Sometimes mistakes will happen. So let's describe a type 1 error. Now remember, just as a reminder, type 1 error. Type 1, we're going to say P is less than alpha. P is less than alpha when it should have been bigger than alpha. Okay? Type 1 is P is going to be less than alpha when it should have been greater than. So P is less than alpha, vice P is greater than alpha. Okay, so if it's less than alpha, we're going to fail to reject the null hypothesis. And I should have rejected the null hypothesis. So the network finds convincing evidence that the true proportion of U.S. adults who watch Miniature Golf with the Stars is greater than 0.12. Yeah, because that's my alternative hypothesis. A p-value that is smaller than alpha has me going, the alternative hypothesis is true. Well, the alternative hypothesis shouldn't have been true. The null hypothesis should have been true. So what's going to happen is I am going to renew that show because I believe enough people watch the show and then no one wants to really watch the show. That's a type 1. Well, a type 2, remember, for type 2, 2 is our big number. For our type 2, since it's big, we're going to say P is greater than alpha. And it should have been smaller than alpha. Vice means on the other hand. Okay, so if we say P is greater than alpha, what that means is we believe H sub 0. We believe the null hypothesis. But since it's in error, we should not have believed the null hypothesis. So if we believe the null hypothesis, well, we find convincing evidence that the true proportion of U.S. adults who watch Miniature Golf with the Stars is greater than 0.12, is not greater than 0.12 when it really is greater than 0.12. This should say is not greater. Is not greater than 0.12 when it really is greater than 0.12. So what's going to happen? We're going to take the show off the air. The show will not renew and when there was enough audience for it. Alrighty? So big picture, type 1 error. Type 1 means our sample says P is less than alpha when P was greater than alpha. And the type 2 is bigger, so P is greater than alpha when in reality it was smaller than alpha, and then all the other rules apply. All right, so remember that after this video, you've got your summaries, so you can take a look at all of that. And let's go ahead and finish up the 9.1 assignment. And if you got questions, please let me know.